Hello and welcome. In this presentation we will be looking at scale factor and specifically what happens to the change in the area of a shape when the side lengths have been increased by a specific factor, which is also called the scale factor. Consider these two shapes. So unit square of 1, area 1, and a square of side lengths 2, which has an area of 4. If I look at the ratio between the side lengths here, so length here of 2, length here of 1, I can state that the scale factor is 2. In other words, I have multiplied each side by a factor of 2. What does that do to the area? Well, my area has gone from a value of 1 to a value of 4. So I can say that the ratio of the areas is 4 divided by 1, or k squared equals 4. And the ratio of the sides, 2 divided by 1, or k equals 2. So just think of k as the scale factor. In other words, what have I done to these side lengths to go from this original shape to this similar shape, and I have multiplied this shape by 2. Likewise, if you look at this shape here, I have multiplied the sides by 2 to give you that shape there. So k equals 2. The ratio of the area would be 8 divided by 2, which equals 4. What about if I multiplied each side by 3? You'll see side length of 1, side length of 3. K equals 3. 3 divided by 1 is 3, and my area here is 9. My area here is 1, so I can say that k squared equals 9. Similar here. Length of 2. Well, this one here is a length of 1, 2, 3, 4, 5, 6. So I can say that 6 divided by 2 is 3. In other words, I am multiplying each side by 3. And what is happening to that area? Well, the area has gone from 18 to an area of, from an area of 2 to an area of 18. In other words, the area has been increased by a factor of 9. Likewise for 4. And you can just have a look at those diagrams there. And the general rule that we use is if two shapes are similar and the scale factor, in other words the ratio of the sides, so compare two sides, any two, that side and that side, look at the ratio, in other words that length divided by that length, so the ratio of the sides is k, we just allocate the letter k, then the ratio of the similar shape is equal to k squared multiplied by the area of the original shape. That's a bit of a mouthful. It's probably a lot easier just to go through a couple of examples. So, okay, we have two triangles here. They are similar. Side length 10, area 40 centimeters squared. Similar triangle. Side length 25 centimeters squared. Area, well, we don't know what that is. That's what we have to calculate. So what I need to do, work out the scale factor. So what am I multiplying that length by to give me 25? Well, quite simple. It's 25 divided by 10, which equals 2.5. So now that I have my scale factor, I want to calculate the area of this triangle. So the area is k squared times the original area. So it'll be 2.5 times my original area, which equals 250 centimetres squared. Look at the next one. Right, we have this area here of 500 centimetres squared. We want to work out this area here. I know that the height of this shape, the original shape, is 12. The height of the similar shape is 60. So first what I do is calculate the scale factor. So scale factor is just the ratio of two similar sides. Right. 60 divided by 12. That equals 5. So my area will be k squared, in other words my scale factor, times the original area. Well, there's my original area here. I'll give you 5 squared times 500 gives you 12,500 centimetres squared. And the final example. So this time we're looking at total surface area. So this particular shape, it's called a triangular prism. Has a total surface area of 160 centimetres squared. Now it's been reduced, and what we need to do is work out the area of this reduced prism. Now the height of this one, 16 centimetres. The height of this one, 4. So first what I need to do is work out the scale factor. It's the ratio of the side lengths. There we go. So the scale factor is 4 divided by 16, which equals 0.25. And the similar area, same approach again, k squared times the original area. Here is my original area. There is my scale factor. So there is the maths there if you want to work that out. So just going back to that original set of words. If two shapes are similar, and they must be similar, and the scale factor, in other words the ratio of the sides is k, then the ratio of the similar shape is equal to k squared multiplied by the area of the original shape. Well, I hope this presentation has answered a few of your questions about scale factor and calculating areas of similar shapes. And until next time, happy maths. Bye for now.